This is video lecture number 2 for chapter 19. You need to have an excellent understanding of how to assign oxidation numbers to understand what we do for the rest of the unit. So now we're going to look at what oxidation and reduction actually are. We did do this earlier in the year, so hopefully it's a review. Oxidation originally meant that a substance combined with oxygen. For instance, gasoline can burn in oxygen to form carbon dioxide and water. Rusting of iron in air or oxygen forms iron 3 oxide. So what is the formula for iron 3 oxide? Fe 3 plus, oxygen minus 2, number common to both is 6, so Fe2O3. So in oxidation, iron reacts with oxygen to form iron 3 oxide. A quick balancing: 3 in front of this oxygen, a 2 in front of this, and then a 4 in front of iron. Reduction is the opposite of oxidation. Originally, it meant the loss of oxygen from a compound. So iron 3 oxide, Fe2O3, plus carbon produces iron. So we lost the oxygen in the iron 3 oxide and carbon dioxide. So if we do a quick check here, again, we have 2 and 3 oxygens, so a 2 in front, a 3 in front, 3 carbons, 4 irons. So oxidation was gaining oxygen. Reduction was the losing of oxygen. Today, we no longer need oxygen in an oxidation-reduction reaction, which we call for short a redox reaction. In a redox reaction, oxidation and reduction both occur at the same time. You can't oxidize something without something being reduced. You can't reduce something without something else being oxidized. In its simplest term, oxidation is the increase in the oxidation number of a reactant as it turns into product. The reason the oxidation number increases is because it loses electrons. Reduction is simply the decrease in oxidation number. This happens because, since electrons are negatively charged, the substance is gaining electrons. So here, iron turns into Fe2+. Its oxidation number increases. That's what oxidation means. The charge goes up. We only deal with the reactant side. Copper 2+ turns into copper. Copper, we know, has an oxidation number of 0. So copper 2+ is reduced. So if we move to the next page, we should be able to summarize a redox reaction. Oxidation, the oxidation number increases because it loses an electron. Reduction, the oxidation number decreases because it gains an electron. So here in oxidation, X loses an electron, so its oxidation number increases. Y gains the electron, and its oxidation number decreases. Earlier in the year, we mentioned an oil rig. So oxidation is the loss of electrons, oil. Reduction, rig, is the gain of electrons. So oxidation, the charge goes up because it loses electrons. Reduction, the charge goes down because it gains electrons. And the only thing we have left is an oxidizing agent and a reducing agent, which we're going to look at on the handout with the worksheets. So if you can get that out, I will flip videos over, or worksheets over right now. So if you can have this worksheet out from the packet, it's the second page. And step 1, we have to assign oxidation numbers, which is why we practiced. So hydrogen by itself, 0. Bromine by itself, 0. HBr, H is +1, and bromine is -1. So what was oxidized? Well, we see hydrogen went from 0 to +1. So the hydrogen, which we're going to represent as H0, was oxidized. Who was reduced, or what was reduced? Bromine went from 0 to -1. So Br was reduced. Its charge went down. In the simplest terms, as far as oxidizing agents, since H0 was oxidized, the other thing is the oxidizing agent, which is Br0. Since Br was reduced, the other thing, H0, is the reducing agent. I will talk more about those because that's the really confusing thing for this part of the chapter. But otherwise, this is it for tonight, video lecture number 2. And have a great night, and we will see you tomorrow.